Jump past question 2002. Question number 9. A body weighing 80 newtons stands in an elevator that is about to move. The force exerted by the floor on the body as the elevator moves upwards with an acceleration of 5 meters per second square x. The force exerted by the floor on the body as the elevator moves upwards with an acceleration of 5 meters per second square x. Our question today is centered on force analysis. Force analysis. Okay, let's see what the question demands. We have an elevator that is targeted to move upwards. We also have a body on the elevator targeted to move downwards. So it's force analysis. You can see two bodies in different directions. Okay, let's start this way. Let's make a pictorial view. Let's presume this is an elevator. The elevator is targeted to move upwards. Then we have a body on the elevator targeted to move downwards. And the weight of the body was given. The weight was 80 Newton. That is the weight of the body on the elevator. Then there is science behind this. And the science is this. Action and reaction are equal but opposite. Action and reaction are equal but opposite. Newton's third law of motion. When a body stands on a base, the base stands back on the body with the same weight of the body. Okay, what do I mean by that? If the body is standing on the elevator with force of 80 Newton, the elevator will also stand back on the body with force of 80 Newton. Action and reaction equal but opposite. That's a simple idea. Okay, so at this point there is equilibrium. But recall the question says that the elevator is about to move upwards. It's about to move upward. So if the elevator must move upward, the elevator must provide two forces. Hey, paying attention. If our elevator must go upward with this body on it, it must provide two forces. Number one, the elevator must pay the price of this weight. The elevator must provide a force that is equal to this weight and an additional force that will bring about a body moving upward. An additional force causing acceleration in upward direction. So these are the two prices that our elevator must pay in order to do what? To move upward. Okay, let's see better. Okay. So my elevator will move with a certain force. If my elevator must go upward, it must go with a force that is 80 plus unknown. Let me call it X. This is the additional force causing acceleration. The additional force causing acceleration. So once the elevator provides this force, it can move upward. Okay, let's go back and solve. To get this additional force, recall F is equal to ma. The force that brought about acceleration in upward direction is not known yet. I don't know the mass of the body that the elevator is moving upward yet, so I'll keep it as m. Then I know the acceleration that the elevator makes upward. It was given in the equation. That is 5 meters per second square. So that additional force is unknown yet because the mass is still an unknown. So I need to go and find this mass in order to get that additional force. So what do? We brainstorm. The weight of the body has been provided. Anybody that has weight is falling downwards. Therefore, it will have an acceleration called acceleration due to gravity. Okay, what do I mean by that? Recall W is equal to mg. So the weight of the body has been given 80 equal to the mass of this body is what I want to find. I already know the G. It's a constant for Mother Earth, 10 meters per second square. Therefore, the mass of that body on the elevator is 80 divided by 10. Mass of the body on the elevator is 8 kg. So this is mass of the body on the elevator, 8 kg. Okay, having known the mass, then I'll go back to find that additional force, making the mass to accelerate upward. Okay, the additional force that's making this body to move upward now becomes the mass 8 times 5. Please pay attention. Mass of a body is constant whether at rest or in motion. Whether a body is at rest or in motion, its mass does not change. It remains the same. Okay, this time the body is moving up. So to maintain that same mass, then we'll be having 8 times 5, 14 Newton. So this is the force making the body to accelerate upward. So to get the total force that our elevator must provide, it will be 80 plus 40, giving me 120 Newton. Force analysis. Okay, paying attention. for an elevator to go up when the body is on it, the elevator must have a force that's equal to the body on it and an additional force. Why? When the elevator has a force less than the body on it, the elevator cannot go up. Instead, the elevator will do what? Will fall down. So for elevator to go upward, it must cancel the weight of the body on it and also have an additional force, as we've proven on the board. So the total force provided by elevator is 120 Newton. No wonder it was able to move upward, because the body on it will come and take away 80 from it. It didn't succeed in cancelling all the motive force, all the upward force provided by the elevator. It still had a net force of 40 Newton that caused its acceleration upward. Okay, this is just like the rule of vector. In opposite direction, we subtract 120 minus 80. We'll be having 40 Newton. And that 40 Newton becomes our net force or resultant force. But the question is demanding for the total force the floor of the elevator gained in order to move upward. That total force is 120 Newton. So going back to our option, you can see the best option there is option B, 120 Newton. Stay tuned, relax as we push on. Please do subscribe.